Hello and welcome back to the Argyle CIO Leadership Forum. My name is Vicki Lynn with Argyle. It's great to have everyone joining us today. Just a couple of notes before I turn things over to our esteemed speaker. First, a quick reminder to stop by our sponsor's virtual booth at any time during the event and for the following week. Our partners are committed to providing you with valuable content and a great overall experience at any time. You can visit those virtual booths from the main agenda page, and those do include complimentary materials, information, and meet and greet opportunities. To ask questions throughout the session, simply type into the Q&A chat and we will address your questions at the end of the session. And now, without further delay, I'd like to introduce our speaker, Jack Brzezinski, Senior AI Architect, Generative AI, UC San Diego. We are so excited to have Jack with us for a keynote presentation titled Smarter AI, Better Decisions, Planning Engines Meet Generative Models. Welcome, Jack, and over to you.
Yeah, thank you so much. I appreciate the opportunity to speak about AI on this platform. I have several use cases that are kind of cutting edge in the generative AI environment, and I wanted to present some of the aspects that might be interesting for this audience that involve really kind of taking advantage of the entire field of artificial intelligence rather than focusing only on the latest and greatest large language model capabilities. The broader idea that I'm trying to convey here is that we are probably maybe 50 or 60 years into research that really kind of created the current generative AI environment, and that research is still very relevant. There is a lot of very useful techniques in knowledge representation, in AI style planning, in reasoning that we can take advantage of if we look at generative AI maybe from a little bit different perspective. So to get into the kind of the foundation for my use cases, at UC San Diego, we have an environment, we call it Triton GPT, and this is really a front end to a number of tools and assistants that are deployed for the employees of UC San Diego and several other also institutions. So we are talking about multiple thousands of users that are kind of using the assistance for their daily jobs. There is also deployments to students on the educational side as well. So what the primary use case that I want to focus on is the application to fund management. And specifically the capabilities of our AI infrastructure to have a conversation with databases and enable structured retrieval using SQL, enable analytics, and while the front end is exactly what we are looking at. The front end is maybe a junior fund manager or advanced fund manager who is looking for a very specific information from enterprise documents or enterprise database systems. So the idea here is that, obviously the back end where I am focusing on has to enable rather complex series of steps where some of those steps are supposed to be executed in parallel. Some of those steps will be executed in a non-deterministic fashion where perhaps we want to skip some of the steps. Perhaps we would like to kind of customize some of the code that is generated in real time to answer user question. So what you are looking at is the kind of back end of the use case where the user in question comes through the front end into the system, and then there's a series of decisions and series of generative AI steps where we are determining whether the question is going to be answered maybe from institutional knowledge that is in PDFs or websites and various resources that are deployed to the vector store. This is the famous RAG infrastructure. There is huge advantages of having institutional knowledge vectorized in RAG because of the sheer power and strength of the search mechanism that is retrieving from the vector store that contains embeddings. So that is the primary advantage, right? The quality of search is enormously high. So the question, if we determine, for example, that the question is going to be kind of looking at maybe kind of document-based answer, like what is the definition of the budget, for example, then the system will choose that particular path and will look into our Onyx infrastructure. That is our backend that is enabling us to retrieve information from vector stores. However, if the information from the user is kind of pointing maybe towards a specific database resource, like what is the budget, but for a specific award, then we know that this question has to be answered accurately and with an up-to-date information, and the only resource that can do that is going to be the database. So the main flow maybe that I would like to focus on is here at the bottom. And so there is essentially an infrastructure that we created that enables us to expand a little bit on the question so that the AI is more aware about the context. For example, can we figure out what kind of table or what kind of view in the database is going to be best to answer a specific question. Then once we have that step figured out, then we begin to generate in real time SQL code. Sometimes the question is going to require multiple SQL statements to be created that point to multiple resources, maybe because there is maybe competing tables or views that answer the same questions, maybe with different type of data, or maybe there's some resources that are maybe more up-to-date or maybe more comprehensive. So the AI has enough back-end information to make those kind of determination. Then there is going to be real-time retrieval from the database to kind of get us the payload that we are interested in. And then there might be now further analytics necessary before we display the answer to the question, because perhaps it's a one-liner, and we just are interested in a single number, right? Or perhaps the question was about all transactions that happened for a specific resource. So the question might be requiring hundreds of rows that are coming back to the AI as payload. So then there is also a generative component here that will have to assess that payload, and perhaps visualization is necessary. So in real time, we will be generating visualization component, or maybe some sort of element that is going to help us maybe compress information, summarize it, right? So this kind of is the main flow. There is obviously several items that are very interesting, but perhaps beyond the scope of this discussion. So I think the main message here is that even though this is a linear step, or linear flow, it doesn't have to be executed in a linear fashion. Perhaps we need to reach into some other boxes within the Triton GPD environment to help us out with the question. So that is the back end. Maybe to kind of further get us closer to the specifics of what we are trying to do here is that the user question might be for example, what are the expenses for the award, in the last 30 days. The SQL statement will be generated based on several, we call it knowledge fragments and knowledge bundles. So part of the architecture was to develop very rich metadata representation about the tables and the views that the AI is looking at. So there is going to be AI-generated descriptions that are, again, probably a separate talk. There is also a very important component where we are sampling the database, because the AI has to have a very good idea what is actually the type of information in each column or in each row. So we have a very high success rate with SQL-generated answers, or more specifically with answers where payload comes back to the AI through the SQL that is generated by AI. It's way over 99% of correct SQL statements. So we are very happy with when it comes to the flow. Now, what is the foundation? And again, the foundation here is metadata, and sometimes we are interested in kind of making a little bit of a decision what kind of metadata is going to be required to actually answer the question. So I'm kind of slowly getting us into this kind of position where we have to think about, okay, which resources do I need? Which resources perhaps I don't need to answer a specific semantics or intent behind the user question, right? So the key to the success is the AI having vast knowledge about the resources that are available in our databases at UC San Diego, and also to institutional knowledge that is perhaps vectorized. Right, so maybe to quickly go over some of them. Right, so Activity Hub knowledge fragments would be basically smaller pieces of information that describe content of the database. Right, and Activity Hub VLKB, very large knowledge fragment, would be perhaps kind of results of computation performed within HANA S4 that is going to give us maybe some sort of an aggregation, maybe some sort of a surface statistical computation where we kind of give the AI maybe larger pieces of information to kind of have in the context of for the reasoning process, right? Right. Perhaps we would like to configure the answers maybe from the user experience point of view. So perhaps we would like to have that component there, or perhaps we would like to configure how users would like to visualize certain answers. Maybe they have preferences. Maybe they would like to have pie charts combined with bar charts and things like that. So as you can see, we can kind of deal with several kind of areas of that define context. I also wanted to point out that some of the data might be vectorized. Some of the data may not be. So perhaps some of the data will be considered to be human understandable VLKF, where we are thinking about maybe letting the experts, domain experts, to kind of look at these knowledge fragments and kind of give us some feedback. Or perhaps there is going to be AI-generated resources that will be kind of also in play, and that's actually the majority of what we got. The majority of metadata that we are generating is coming in that domain. Right. So then, okay. So looking a little bit differently at our architecture, we have now a situation where there is some sort of a user question that is going into this kind of environment where we are kind of interested in making a decision. Like, okay, so what do? We have multiple resources. Not all of them have to be executed deterministically. Maybe we can kind of pick and choose about the tool that is going to be the most appropriate one to answer. Now, this is the kind of MCP framework that I wanted to kind of use as maybe like a software environment for our discussion. And as you can see here, we can kind of make decisions at various stages of the question answering process. So, for example, perhaps the agent that is asking the MCP client, so to speak, is going to make a decision, okay, where we go. Maybe we will go to server 1 that has access to tools 1, 2, 3, right? So maybe those will be the data analytics tools. But maybe we don't need to do that. So maybe server number 2 is going to be, maybe MCP server 2 is going to be more helpful in maybe summarizing textual documents that we would like to have insight into, right? So there is. Or maybe there is an agent-to-agent environment that is kind of maybe a different path. So again, what I'm trying to convey here is that there needs to be there's an opportunity here to have a lot of intelligence at various client and server stages to pick the right tool, and even more importantly, because it's most likely that the tools will not be kind of like one by one, right? We probably need to have an ensemble of tools, because the first tool probably will generate SQL, the second tool will retrieve, the third tool will evaluate. So there is probably an opportunity to have multiple tools that will be orchestrated, lined up in a sequence that is non-deterministic. Right. So what can we do here? Well, like we already are pretty familiar, probably most of this audience, I'm pretty sure, is probably familiar with this deep reasoning or deep research capabilities, depending on the LLM that you use. There's going to be some sort of a planning or thinking process that is available within the LLM framework that we might be using. But then there is another thing that I mentioned at the beginning, right? There's decades of research in logic, right, in reasoning processes, in AI style planning that might give us additional capabilities to actually orchestrate what the AI is supposed to be doing, and what is the kind of maybe more appropriate, more knowledge driven, or more kind of tailored approach to a specific problem that we are trying to solve, rather than going with the general purpose LLM solutions that are very impressive. There's no question about that. But here on the left hand, we have a reasoning or planning process that is tailored towards the solution that we are interested in. So if we look at AI as those kind of like engines that are making sense of things, then we don't have to use the knowledge of planning that is kind of in the box. We can give it to the AI, and the AI will make sense of this. Now, what we are looking at here is an example where there is a modal logic formulation of the problem, where there might be the concept of necessity, for example, in a logical system, right? Like what are the things that I absolutely need versus something that might be optional in my reasoning process. And what I'm observing is that this is a very powerful amplifier to the knowledge that you might already have in your AI, represented as knowledge graphs or as your RAG documents, or whatever context representation you are choosing. Also, explicit planning, where, for example, in AI, we know very well that planning is about selecting a sequence of steps that meet a precondition. This is coming from the robotic world, or a kind of like block world research, where you are moving things around spatially, for example. But the same reasoning process can be applied to problem solving, like, for example, answering questions with SQL. So here, I'm explicitly saying, hey, look at the preconditions for my current step in the plan, right? Do I have the SQL statement that is generated, right? Do I have maybe some other things that I have to take care before I start answering the question, right? So then there is going to be maybe a discussion about what is the post conditions, right? So let's say I execute SQL. What is going to be what is going to be the outcome, right? What is the property of the outcome, and maybe perhaps I'm missing something, right? So here, right, there's this opportunity, because and this is kind of like a really simple hello world example of a call to a tool, right? That we will have a list of tools, and I can see maybe in some of the questions that are coming in, right? How do I determine what is available to me? Well, I will have to describe those tools to the AI and kind of get some background to those tools, right? So essentially, what I'm trying to say is that, well, if I have an MCP server and I got some tool knowledge that is available, and those tools could be Python programs, those could be Java programs that exist somewhere in the organization, or maybe even some other resources, right? If we decorate, right, I think the tool, the AI tooling jargon is decorating the tools with description. If we can describe the tools to the AIs, then the AIs will be able to reason about the applicability of the tool, the order and sequencing of the application, using the explicit maybe planning constraints that I'm teaching, and subjecting the AI to kind of taking it as a primary consideration. Right. So I guess so maybe the last slide here that I wanted to kind of get into is, okay, so if we how do we orchestrate this? Well, we can have now the explicit AI framework that enables us to analyze for each step or each tool or each problem formulation. We are able to specify explicitly what are the preconditions for the action that this tool can have. What would be the action that actually can be done, and what will be the post conditions, right? How the preconditions have been changed into post conditions so that maybe another tool can pick it up, right? And then there's several kind of key components here, right? I want to be able for the AI, not just LLM in the box, but my AI algorithm to order the process, the solution process. I would like to be able to maybe filter out some of the tools that might be not necessary or not appropriate for the current problem at hand. And then what is the next step, right? I executed a tool. Do I know exactly what is supposed to be happening next? And perhaps my initial order is going to be changing because of the post conditions of the tool that I just generated. Perhaps the question is answered. I don't need anything for clarification. Maybe I don't need anything for visualization. Maybe I don't need to run a clustering algorithm on the payload because we know that the user doesn't need that, right? So this is a high level overview of a explicit planning and orchestration using the AI knowledge that we have for so many decades, and probably it makes a lot of sense to kind of not forget about that and maybe not rely 100% on the deep research or deep planning capabilities of the LLMs, because those planning steps, while they might be great, they are probably not going to be exactly what we might want for our enterprise application. So this is kind of the main kind of ideas that I wanted to convey here, based on our Triton GPT architecture that is currently in place at UC San Diego. Okay, so I see a few questions here. So let me maybe go into this. So how does the enterprise data agent determine which tools or models to use given a task, right? So this is obviously this is a metadata question, right? So I have to have a tool description available for the AI so that the AI is aware what are the possibilities to solve the problems, right? So the tool description is basically a long way, a short way of saying that I need to describe what the program is doing. Perhaps it's another AI module, or maybe it's just a Python code that is creating pie charts, right? So I have to explain this to the AI so that the AI is aware of the capability that is in place. How do you ensure smooth orchestration between local and cloud-based LLMs, especially in a multi-cloud environment, right? So this is a profiling, system profiling question. We are in an environment where we can run an ensemble environment, where some of the models are actually local models that are deployed within our DSMLP supercomputing centers within UC San Diego. We also have access to Azure and Google models. So sometimes they are working as an ensemble to actually answer the same question or select from the tool set, and then one of the models will be acting as a judge, right? So this is a system profiling question. We know exactly. I'm kind of trying to convey this. We know exactly how much time each step is going to be taking, and we basically kind of very, very closely monitor. We are monitoring those numbers very closely. One more question: which industries or business functions have seen the most value in the implementation? Right. So this is basically very broad use case, right? We are talking here about enterprise AI data readiness in the structured world, right? This flow that I'm discussing here basically replaces the use of the BI tools, because instead of going to a dashboard or creating some sort of a Power BI dashboard, we can have a direct conversation with tables, with visualizations, with modeling, and all that stuff. So the use cases are here extremely broad. Right now, our use case at UC San Diego is exactly that, right? Replacing traditional BI tools with a generative approach. Coordination of multiple AI models and tools. Right, so it's a very deep question. Our framework is based on the Light LLM framework, where you can basically manage multiple large language models within the organization with profiling, with traffic monitoring, with resource allocation. So the management is a very deep question. I'm also kind of, this is probably a topic for another discussion, but I'm in also part of the architecture here is small fine-tuned models. Not all the LLMs will have to be kind of the latest and greatest. There is a lot of capabilities with very small, therefore not expensive to run, the low cost for the token situation, where the model is actually fine-tuned on the capabilities that we are looking at, which is a very attractive proposition in terms of quality and also cost of execution. So this is basically the architecture I wanted to present, and thank you so much for your attention.
Thank you so much, Jack. What an incredible keynote. We really appreciate it. I'm sure you're going to get some questions, more questions than we already had. I want to thank everyone for joining us for this session and remind you that this session, along with all of today's content, will be available on demand following the event. Our next session will begin at 1:45 p.m. Eastern Time, and that will be a keynote presentation titled From Automation to Autonomy, how IT leaders are navigating from GPT to autonomized operations and beyond. Please click on the join button that will appear on your screen to be directed to that session. We look forward to seeing you there. Thank you again, Jack.
Thank you so much.